Alright, so blue was f of x. It's our position. And what we're doing right now is we're analyzing at different x values the steepness of their derivatives. Okay? So the one that we're going to look at right now is that we want to see what is the steepness here. You guys said it looked like a negative 3. So negative 1, negative 2, negative 3. I'm drawing what that derivative's value would be. Because I'm trying to draw on top of this f of x blue position graph an f prime of x velocity graph. Okay? So I said from here to here, the slope was 0. Everything in between, let's give it another number. What would the slope be at this x value? So if I drew a quick little slope on that position, give that a number. It kind of looks like negative 3 still, right?
Yeah.
So we're going to put that at y equals negative 3. Now, let me ask you this. Between this slope of 0 and this slope of 0, aka here and here on the position function, when is it the most steep negative? Right in the middle, when x is 0. So it is the most steep negative right here. That means it will be the most negative on the graph that we're about to draw. We go back to 0. Now let's do a number here. What number does this steepness look like? Because we're drawing small little f primes. About 3. So we'll come up here about 3. And then what's the steepness, let's say, here?
6.
A lot, right? It's high.
I'll say 12.
Okay, so what we just did, you ready? We're going to connect these dots that we just drew. And it's a kind of rough sketch, but pretty close. We're going to call this f prime. Looks like a parabola. This is no coincidence. The original f of x looked like a what? A cubic. It looks like a cubic function of some sort. So the derivative of a cubic function would be a quadratic. Like if I told you derive x cubed, you'd say 3x squared. If I derived x squared, what would I get? 2x, which is a linear graph. So let's do that real quick. Now, don't look at blue. Don't look at the blue position function anymore. Don't look at it. Imagine that you're just looking at this parabola. The most important thing that I think you should gravitate toward is the fact that this horizontal tangent way down here is what value? 0. So I'm going to go and now put y equals 0. And I'm going to do what I just did to the blue graph, but I'm going to do it on this red graph. What's the steepness of that?
-6.
-6. Let's do -6. So right here, at that x value.
Way less steep than the one you called.
Yeah, it is. Let's do like -3 then. Okay. So this is like -3. So 1, 2, -3. There's my y value. You with me? Do you see what it's doing now? To where if I keep going here, which is this x value, this is going to be even steeper and it's negative. So even steeper means go lower on the y-axis and make them meet as far as where they should be as far as a value goes. And sure enough, that value is probably going to be about right here. And you can see that your f double prime is a linear function. Okay? So f double prime is a linear function of some sort. And it would go this way as well. What up? Oh, yeah, go ahead.
Never mind.
You sure?
Yeah. Ask it, Christian. Ask it.
Go for it.
When you're trying to make the linear graph, are you using the points, like exact points that you drew on the red graph, or is like you took the main point?
Oh, I'm using different points. I'm just trying to show you the steepness of these slopes on the graph.
So
It doesn't matter,
as
no.
long as it's on.
Because it's a rough sketch, but at the same time, you're understanding what's going on. Because I'm relating, ultimately, hopefully you can see the relationship that exists between all of these. Okay? Now you tell me, what does the slope of the purple graph look like? It's constant. That's huge. It's a constant slope. And it will be a horizontal as far as the fourth derivative. Give me a number. How steep does the purple graph look?
6.
Positive 6. I think 4. Okay, so let's go 4. Y is equal to 4. This is the fourth derivative, and it is a constant. Okay? Our third derivative, oh, my bad. This,
That's a third. You skipped one.
did I?
You skipped 3.
You skipped 3.
Oh, I skipped through. No worries.
The horizontal line is 3.
Here we go. This right here, the horizontal line is 3. And look at this. Y'all are freaking out, but I'm going to fix it just real quick and in a hurry. What? What's up? Okay, anyway. So this is triple. Cool? Crisis averted.
So would like the fourth one be at like 1 point at 0? Or
Oh, here's a question.
is it still a line?
It's still a line.
I don't think it exists.
So the fourth derivative, can someone tell me what is the slope of the third derivative? 0. So it will be y equals 0 is the fourth, whoops, not that, x, is the fourth derivative. Because the slope, check this out, is 0. So we went from a cubic to a quadratic to a linear to a constant and to 0. And yes, if you keep doing 0, it'll remain at 0. Because the derivative of that is still 0, is still 0, is still 0.
But I thought you said when we were going over derivatives originally that I went from going like 3D to 2D to like a line to like.
Let's not get all
So, listen, we're looking
Is that-
at, we're looking at rates, this is a good O. We're looking at rates of change. We're not looking where it occurs. That's an infinitely small point that doesn't exist. We're looking at what is the slope and what's the steepness of it and how fast is it changing, healing, growing, whatever it is. Yeah.
So this is just out of curiosity. So you start out with x cubed, and like if you follow the pattern, you take away 1 from the exponent. So if it's x to the 0th in the third derivative, is it x to the negative 1 is 0, or like
So what he's saying is this.
going from the third to the fourth derivative?
So if you're saying like, if you're doing power rule per se, you get 2x squared, or sorry, 3x squared, right? You get 6x, then what do you get? 6, then you get 0, and so on and so forth. Because x to the 0, it stops. You can't keep going x to the negative 1.
So it's
X,
not a pattern of just taking away 1 from the exponent,
no.
like okay.
This is good because you're about to get a worksheet on this. So your best thing that I'll say is this. And Alec is he's ahead right now with the question that he's asking. Here's the relationship ultimately that I want you guys to see today. And if you can see it today, the graphing is totally cake. Because you're seeing this a whole 2 units early. Okay? And you get bonus points if you can figure out these graphs here in just a bit that I'm going to give you before you leave. Okay? If something's derivative is positive, then the previous function above, its f, is increasing. If something's derivative is negative, then its previous function above was decreasing.
Do you mean like the rate of change?
The rate of, okay, so yes. So if the rate of change of this function is positive, then this function was increasing.
So basically the rate of change is the slope of the derivative.
Yeah. And the rate of change can tell you what the position function is doing without looking at it. If you see the derivative function and it's positive, you can imagine that f is increasing. And what's awesome about this relationship is it works with a second derivative versus one level down. It works the same way. It's always one level away from it. So guys, let's go back and put this as f prime. You tell me, what would f prime of x equals 0 say about f?
The slope is 0.
It's not increasing or decreasing.
Yeah, straight line.
It's just either a constant straight line or it's just a point that's not increasing or decreasing. So we could say, is it constant or neither? Increasing or decreasing?
Would have to be constant.
What would the derivative look like if it were a vertical line, if it was undefined?
You could not do that with this because you can't derive a vertical line because it's not a function.
Okay.
It has to be a function to be differentiable or an opportunity for you to take a derivative of it.
So the graph of each next derivative just shows rate of change, right?
Yep, here we go. Ready? Here we go. So let's look at blue and red. Red is positive. F prime of x is positive right here. And f prime of x is positive right here. And it makes sense because that means that f of x is increasing. And increasing.
Oh,
You with me? Watch this. F prime of x is negative here. And that makes sense. Because the original function was what? Decreasing there. Do we understand all that? Alright. I have 6 graphs for you. And what you're going to do is you're going to determine which one's f, which one's f prime, and which one's f double prime. You may try to do this at first and it looks like it'll work, but it has to work between all 3 levels. There's 6 of them. I'll give you 100 points for each one that you can solve. And if you can get all 6, I will double your score.
alright.
Alright?